Hi everyone, welcome to GoClasses. In this session, we will solve some GATE PYQs, some GATE previous year questions on machine instructions. In the previous lectures, we have seen all the different type of machine instructions. We have seen arithmetic instructions, logical instructions, data transfer instructions, and transfer of control instructions like jump instruction, conditional and unconditional jump instructions. Okay. So in the previous lectures, we have also seen some arithmetic and logical operations like shift operation, there is a rotate operation and compare instruction. So basically all the different type of machine instructions we have already seen in our previous lectures. Now in this lecture, we are going to solve some GATE previous year questions based on machine instructions. Okay. So let's start with this question. This is GATE 2003 question. You can see, and these are the options. These are the 4 options. So let's solve this question. The question is saying, consider the following assembly language program. This assembly language program is given to you for a hypothetical processor. ABC, these are 8-bit registers. So remember ABC, these are registers which are 8-bit registers. The meaning of various instructions are already given to you. So you can see that is the semantics. This is the meaning of these instructions. Okay, these are the assembly language instructions and their meaning is also given to you. So you can see what this instruction means. This instruction means move B0, means this value 0 you put in the register B. So you can see this meaning is already given to you, that the register B now contains the value 0. This instruction, this means that in the register C you put the value 8. This instruction, this is compare instruction, compare C with 0. Okay, so like this. So you can see these assembly language instructions are given to you and these meanings are also given to you. Now what the question is asking, the question is asking if the initial value of register A is A0, the initial value of register A, that is A0, then the value of register B after the program execution will be. Okay, so this is the question, means after the program execution, when you reach here, okay, at the end of the program execution, when you reach at this line X, at this location X, then at that point of time, what is the value in the register B? What is the value of register B? These are the options. You can see the value in register B after the program execution will be, these are the options: the number of 0 bits in A0, the number of 1 bits in A0, A0 itself, or I can say the option D, that is 8. Okay, so this is the question. I hope you understood the question. Now let's solve this question. Okay, let's solve. So one by one, let's solve this question. The question is saying that initially what we are doing, this is the first instruction, right? This is the first instruction. So tell me what this instruction will do. Tell me what this first instruction is going to do. This move instruction, this will put the value 0 in the register B. Yes or no? Okay, very simple. You tell me one thing, the move instruction, can it affect the flags? Can it affect the 0 flag, carry flag, all the status flags that you have, sign flag, parity flag, auxiliary carry flag, okay, or the overflow flag? So you can see these 2 instructions, they do not affect the flag that you already know. Okay, so let me write it here. That move instruction, that point you already know. We have already seen in our lectures that move instruction. Okay, move, or I can say load, store, push, pop. Okay, these instructions, push, pop, these instructions, what they do not do, these instructions, they do not affect any status flag. Yes or no? They do not affect any status flag. Any status flag, whether it is carry flag, 0 flag, whatever flag you take, that will not be affected. Okay, so these instructions, these data transfer instructions like move, load, store, push, pop, these instructions, they do not affect the any status flag, carry flag, 0 flag, parity flag, whatever flag you take, that will not be affected by these instructions. Okay, so these instructions are very simple. B has 0, C has 8, very simple. Now remember, these are 8-bit registers. So what B has, tell me what content B has. Let me know what content B has. B has this content, right? Yes or no? Because these are 8-bit registers. So B has all 0. And what C has? Tell me what C has. C is also 8-bit register, right? So this value 8 in the binary, that will be like this. Yes or no? 0 0 0 0 1 0 0 0. Very simple. Now what the next instruction? The next instruction, remember, this is just a label. Yes or no? This is just a label, or I can say this is just a memory address. Yes or no? This is just a memory address. So remember this Z, this is just a label. Now this instruction is saying compare C with 0. Compare C with 0. Okay. So this instruction, this compare instruction will affect the flag that you already know. Yes or no? The compare instruction will affect the flag. How? Please tell me. Let's discuss the compare instruction. You have a compare instruction. In the compare instruction, let's assume you have X, you have Y. This is your compare instruction. Then internally, what this instruction will do? Tell me internally what this instruction will do. Internally, this instruction will execute X minus Y. Yes or no? So internally, this instruction will do the subtraction X minus Y. But remember, in this instruction, X and Y, they are unaffected. Yes or no? You can see in this instruction, operands will be unchanged. Operands will remain unchanged. Yes or no? Because you are doing the comparison. So do not change the operands. Means X value, Y value, that will not change because of this instruction. Okay, because of this compare instruction, the operands will remain unchanged. Yes or no? So all these points in our previous lectures we have already seen. So operands will remain unchanged. Internally, this compare instruction will invoke this subtraction. Internally, this will happen. The subtraction will happen X minus Y. Now, what will happen? This instruction, this compare instruction will affect the carry flag, 0 flag. So how those flags will be affected? So tell me how those flags will be affected because of this because of this compare instruction. The 0 flag will be affected. The 0 flag will be affected. How? You can see the 0 flag will be set if this X minus Y is 0. Yes or no? This 0 flag will be set. This 0 flag will be set if X minus Y is 0. That means X is equal to Y. If X is equal to Y, then 0 flag will be set. Okay, yes or no? If this X minus Y, if the result is 0, then 0 flag will be set. This result is 0, X minus Y. If this result is 0, then 0 flag will be set. So I can say 0 flag will be set if X is equal to Y. Otherwise, what will happen? The 0 flag will be not set. Okay, if X is not equal to Y, then 0 flag will not be set. We have already seen in the previous lectures. What about carry flag? What about carry flag? What will happen in the carry flag? You can see the carry flag. I told you that for the subtraction, this carry flag acts like a borrow. Yes or no? This carry flag for subtraction operation, because in this compare instruction, internally subtraction will happen. Internally subtraction will happen. I told you, if you remember, I told you that for subtraction operation, this carry flag basically it acts like borrow. Okay, this carry flag acts like borrow. It acts like, okay, I can say this carry flag you can use to represent borrow. This carry flag you can use to represent borrow. Okay, is this clear? So very simple, this carry flag, you can use this carry flag to represent borrow. Okay, acts like borrow. So simple, very simple point. So tell me, in which situation you need borrow? The carry flag will be set when you need borrow. Yes or no? The carry flag will be set when you need borrow. In which situation you will need borrow? When you are doing the subtraction X minus Y. If you do the subtraction, then in which case you will need borrow? You will need borrow if X is less than Y. You will need borrow if X is less than Y. In other case, if you don't need borrow, then carry flag will be reset. Okay, so this is what we have already seen. Very simple. So let's come to this question. This is the compare instruction. So tell me, this compare instruction, what it will do? It will compare with 0. It will compare the value of C with 0. The value of C is 8. So 8 minus 0, it will basically do. Now tell me, what will happen to the 0 flag? What will happen to the carry flag? What will be the value of 0 flag? So you can see these two are not equal. Yes or no? The value of C is not equal to 0. So 0 flag will not be set. Or what about carry flag? Because you are subtracting C minus 0. What you are doing? You are doing C minus 0. C minus 0. 8 minus 0. So you can see there is no need to borrow. There is no need to borrow. So carry flag will also be 0. Is this clear? So these are the three instructions. Very simple. What the next instruction saying? The next instruction is saying that jump if Z. Jump if Z means jump to X if 0 flag is set. Okay, this is the meaning. Jump to location Z. Sorry, jump to location X. Jump to location X. This is the location X. Jump here if 0 flag is set. If 0 flag is set, but you can see 0 flag is not set. Okay, 0 flag is not set. You tell me one thing. when the zero flag will be set after this instruction? Please tell me. Means basically I'm asking when this instruction will actually satisfy, when the condition will actually satisfy. Please tell me. See, after this instruction, you are checking. After this instruction, you are checking the zero flag. If the zero flag is set, then you jump to this directly. You jump to the location X. So this will happen when C is zero. Very simple. Okay, when C is zero, when C equal to zero, then this will actually satisfy. Then this will actually satisfy. Yes or no? Is this clear? Very simple. So when C will become zero, actually C is 8. Right now C is 8, but when C will become zero, then actually this condition will satisfy, and then you will jump to X. Okay, right now this condition is not satisfied because you can easily see zero flag is not set. So this condition is not satisfied. Now you will go to the next instruction. Where you will go? You will go to the next instruction. That is your subtraction instruction. Okay, so the subtraction instruction, what it will do? Please tell me. This subtraction instruction, what it will do? If you have subtraction X comma Y, that simply means that in X you are putting X minus Y. How the flags will be affected? How the flags will be affected? Tell me. How the zero flag will be affected? Because of this subtraction instruction, how the zero flag will be affected? I can say this zero flag, it will be set when the result is zero. When the result is zero, means I can say when the result is zero, it means X is equal to Y. Okay, so you can see. Otherwise, if X is not equal to Y, then I can say zero flag will not be set. What about carry flag? What about carry flag? You can see carry flag, that will be set when you need to borrow, when there is need to borrow. Okay, there is need to borrow if X is less than Y. If X is less than Y, then there is need to borrow, right? Okay, so this is actually, it's like you can consider this as a borrow. Represents borrow. This will represent borrow. This carry flag will represent borrow. So when X is less than Y, you are subtracting Y from X. Okay, so when X is less than Y, then you need to borrow. So then carry flag will be set. Otherwise, what will happen? Carry flag will be reset if X is greater than equal to Y. So remember, these two flags are also affected. Zero flag, carry flag, these are also affected because of this subtraction instruction. So you tell me, after this subtraction instruction, what will happen to the carry flag? After this subtraction instruction, you are doing C. In the C, you are putting C minus 1. So I can say C value will become 7. You know, C value, that will become 7. What will happen to the carry flag? What will happen to the carry flag? Please tell me. After the subtraction operation, you can see 8 minus 1. So there is no need to borrow. So the carry flag is reset. What will happen to the zero flag? What will happen to the zero flag? Okay, here you can see the result is not zero. So the zero flag is also reset. So these three things will happen. Is this clear? Very simple. So carry flag 0 and zero flag, that is also 0. Now let's go to the next instruction. So you can easily see so far what has happened. Notice so far what has happened. You just remember one thing. You just remember one thing, that this instruction, this Z instruction, this will satisfy when, remember, this will satisfy when C equal to 0. Okay. So this will satisfy when C equal to 0. This is the one thing. The second thing, here you can easily notice that now C value has become 7 and now carry flag has become 0 and zero flag has become 0. Okay. Now the next instruction is right rotate through carry. Okay. This next instruction, what is this? This is a rotate right through carry, or I can say right rotate. You can say right rotate through carry. This instruction we have already seen in our previous lectures. So this is right rotate through carry. Yes or no? So what this instruction is saying? Remember, this instruction is using the A. And what is the value of A? In the question already the value of A is given to you, that is A0. Basically the value of A, we don't know the value of A. There is some value in A. There is some value in A. I don't know what is the value in A, but there is some value in A. In the question, this is already given. Don't worry. If you notice, read the question, everything is given, that initially the value in register A is A0. Is this clear? So this information is given in the question. Yes or no? You can see the initial value of register A, that is A0. Some value. Okay, so let's assume this A0. Let's assume this A0. Now you notice the options and tell me if you assume some value of A0, will you make number of 0 bits equal to number of 1 bits? Please tell me. Will you make number of 0 bits equal to number of 1 bits? See, the options are saying the answer. What is the answer? Means what is the value of B after the program execution? The number of zeros in A, the number of ones in A. So what you will make sure? What you will make sure? You will make sure that number of 0 is not equal to number of ones. Yes or no? So just make sure that number of zeros is not equal to number of ones. Okay, so take this type of data you can take. For example, you can take this type of data. This type of data you can take. Is this clear? Let me know. This type of data you can take, or maybe, for example, you can take this type of data. So here you can notice, sorry, here we have taken 4 ones, right? Okay, so whatever. So you can say 1 1. Okay, like this. Maybe just let me take. Okay, so let's consider this. Now you can notice what I have done. See, intentionally I have taken in this A0, there are 3 zeros and there are 5 ones. Okay, intentionally I have taken this. I'm making sure that number of zeros is not equal to number of ones. Now you can notice there are 5 ones, there is 3 zeros, so that these options I can eliminate. I can eliminate these options. Okay, now let's move on. Okay, now let's come back to this question. So the value of A we have already taken. What is the value of A we have taken? What is the value of A? Initial value of A we have taken. So what is that? We have taken the initial value of A equal to 0 1 1 0 1 1 0 1. Yes or no? So that's like in the hexadecimal, this A is 6. Okay, so 6 and 13. So you can say basically 0 1 1 0 0 1 1 0 1 1 0 1. Okay, this is the initial value of A that we have taken. Okay, now you tell me what will happen. This instruction is RRC A1. This is the instruction. Okay, what this instruction means, that is already given to you in the question. Every information is given in the question. Every information that is already given in the question. What this instruction means, that is given. Write rotate A through carry 1 bit. Okay, you need to write rotate through carry. Write rotate through carry. Thus, what will happen? If the initial value of A and the carry flag are these, if these are the initial values, then their values after the execution of this instruction will become like this and A0 respectively. Okay, so actually what will happen, let me tell you. What you will do, you will do the write rotate through carry. You will do write rotate. Every bit you will shift to the right. This is what you are going to do. Every bit you will shift to the right. 0 1 1 0 1 1 0 1. Okay, and this is your carry flag. What is the value in the carry flag? Before execution of this instruction, what the value in the carry flag? The value in the carry flag, that is 0. Yes or no? Value in the carry flag, that is 0. Value in the carry flag is 0. So what this instruction will do? It will do the right rotate. Every bit will shift to the right. Yes or no? Every bit will shift to the right. Every bit is shifting to the right. Very simple. Every bit will shift to the right. Now this is right rotate through carry. Right rotate through carry. So this bit will go here and this bit will go here. Okay, this is what will happen. All these details are already given to you. Okay, all these details are already given to you. Shivam is asking how I am taking the value of A. See, value of A is A0. I am taking a random value. I am taking a random. This is a random value I have taken. Is this clear, Shivam? But if you notice the options are like this. The number of zeros in A0, the number of ones in A0. So to make sure that I can eliminate these options, I'm making sure that number of zeros and number of ones, they are not same. So here number of zeros actually is 3, number of ones is 5. Is this understood? Please tell me, Shivam. See, this A0, this value is random. I am taking a random value. Please understand. I am taking it randomly. I have taken this value randomly, but because of these options, if you look at the options, because of the options, I am making sure that the number of zeros and number of ones are different. Okay, because of the options, I am making sure number of zeros and number of ones are different. This is what I am doing. Is this clear? But the values are random. Okay, anyway, so you tell me here what will happen. So after this instruction, what will be the value in A and what will be the value in carry flag? Please tell me. After the execution of this instruction, you can see finally The value in A, that will be 0, 0, 1, 1, 0, 1, 1, 0. And the value in carry flag, that will be 1. Is this clear? This is what will happen. So you can easily see, after this instruction, the carry flag has become 1. Okay, the carry flag has become 1. After this instruction, what has happened? Let me tell you. This has happened that carry flag has become 1. Right? Yes or no? After this instruction. Okay. Why carry flag became 1? Anyone? Anyone want to tell me why carry flag became 1? Why carry flag became 1? Because you can see the MSB of A was 1. Yes or no? Because this is right rotate. You are doing the right rotate. So the carry flag is becoming 1 because this MSB was 1. Understood? Please tell me. Because this MSB was 1, so the carry flag has become 1. Okay, is this clear? Please tell me. Let me know. So very simple. Now let's see the next. Now you tell me what this instruction means. Jump if carry flag is set. Is carry flag set? Tell me. Is carry flag set? Yes, carry flag is set. Yes, carry flag is set. So jump to Y. So now where you will go? Now you will go to Y. Okay, and what you will do? You will do B plus 1. So here the value of B will become 1. Okay, the value of B will become 1. Initially the value of B is 0. Initially the value of B was 0. Now the value of B has become 1. Okay, is this clear? Because carry flag is set, so jump to the location Y. Jump to the location Y. In the location Y, there is a add instruction. There is a add instruction. So very simple point. Now this value of B, that has become 1. Now you tell me one more thing. One more thing. Because of this addition instruction, the carry flag will be affected or not? Now what is the new value of carry flag? Please tell me. Because of this addition instruction, the carry flag will be affected or not? Because of this addition instruction, the carry flag value will be what? The carry flag will be value will be what? That will be affected. That will be 0 because there is no carry. Yes or no? There is no carry, right? Yes or no? You are doing 0 plus 1. You are doing 0 plus 1. There is no carry. There is no carry. So here you can see the carry flag will become 0. Okay, then you will do jump Z. This is unconditional jump. Yes or no? What is this? This is unconditional jump. So the meaning is given to you. Jump to Z. Jump to Z. Now again you will go here. You will jump to Z. Is this clear? Where you are going, you are jumping to Z. So now again you will jump to Z. Very simple. So again you will from here. Remember, from here where you will go. From here you will go to jump to Z. So let me mark like this, that you are jumping to Z. From here you will go here. Is this understood? Please tell me. All these points, are they clear? Now let's see what will happen. Now in the next iteration, what will happen? Tell me. In the next iteration, remember the value of A has become, now this was the value of A. This is the new value of A, 0, 0, 1, 1. The new value of A. Let me, the new value of A. What is the new value of A? That is 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 0, 0, 1, 1, 0. This is the new value of A. Okay. Now let's see the next. Now where you are? Now again you are here. The one iteration is over. Understood? The first iteration is over. Now we are doing the second iteration. Now we are doing the second iteration. Is this clear? Now we are doing second iteration. The first iteration is over. Okay, understood? So Shivam is asking, sir, value of A is random. If LSB is 0, then carry flag. Yeah, I have taken randomly. Shivam, you will understand. Just wait. Just take your copy pen. You will understand everything. Actually, we are trying to understand this program. That is our target. Okay, we are not doing random things. Remember, we are trying to understand what this program is doing. Once you understand what this program is doing, then you can solve any question easily. Yes or no? So first, we are trying to understand what this program is doing. Okay, remember, in this question, what is our final target? Our final target is to find the value of B. Yes or no? What is our final target in this question? Please tell me. Our final target in this question, that is, what is the value of B? That is value of B after execution is over. After execution is over. So focus on the value of B. Is this clear? Focus on the value of B, because the question is asking what is the value of B? What is the value of register B after the program, after the execution is over? So focus on the value of B. Okay, now let's move on. So, okay, now let's see. So the second iteration I'm starting. Let's start the second iteration. Can you take your copy pen? Can you do it with me? So tell me, in this second iteration, you tell me what the value, what was actually value of Y? Sorry, what was value of C? That has become 7, right? Yes or no? So in the second iteration, I'm writing all the things in the second iteration, in the beginning of the second iteration, because now the second iteration is starting. Okay, now the second iteration is starting. So let me write it here that this second iteration. Now we will start the second iteration, but remember, before you start the second iteration, just make sure you know the value. So the value of C was 7. The value of B has become 1, that you already know. Value of B, that has become 1. Value of A, what is that? Value of A, what is that? That is 0, 0, 1, 1, 0, 1, 1, 0. Yes or no? 0, 0, 1, 1, 0, 1, 1, 0. Okay, so this is the value of A. What was the value of carry flag? Tell me quickly. The value of carry flag has become 0 because of this instruction. Because of this addition instruction, the carry flag has become 0. You already know. Here the carry flag has become already 0. Okay, here 0 flag. What about the 0 flag? Because that also has become 0. Yes or no? So 0 flag also has become 0. So you can see 0 flag that also become 0 because of this addition instruction. I am talking about this addition instruction. Because of this addition instruction, the 0 flag also has become 0. You did not set the 0 flag. Very simple. Okay. Now this comparison will happen. After this comparison, what will happen? Quickly tell me. You will compare with 0. You are comparing the value of C with 0. The value of C is actually 7. You are comparing 7 with 0. So what will happen? The 0 flag will be 0. And what about carry flag? The carry flag also will be 0. Yes or no? So because of this compare instruction, 0 flag, carry flag, they will become 0, 0. Very simple. Yes or no? Is this clear? Because you are doing the comparison. You are comparing the value, this value C, you are comparing here. So these will be affected. After that, what will happen? After that, what will happen? This JZ. Okay, jump. So this actually, this will be successful when C equal to 0. So this is unsuccessful because C is actually 7. Yes or no? So this is actually unsuccessful. So this is unsuccessful. Okay. Now you will go to this instruction. What will happen in this instruction? The C value has become 6 now. Now the C value has become 6. Okay. What about carry flag? That has become 0. What about 0 flag? That has become 0. Simple. The C value has become 6. In this instruction, what will happen? Now notice in this instruction, what will happen? You already know what is the carry flag. This is the value of A, and what is the value of carry flag? What is the value of carry flag? The carry flag is 0. The carry flag is 0. Now when you do this RRC, what will happen? Now if you execute right rotate A one time, right rotate A one time. So now what will be the next value of A? And what will be the next value of carry flag? Please tell me. You are doing the right rotate. Yes or no? You will do the right rotate. Every bit will move to the right. Every bit will move to the right. This will go here. And this 0 will go here. Every bit will move to the right. So this is what will happen. So you can see the next value will be 0, 0, 0, 1, 1, 0, 1, 1. Correct, correct. Okay. And the carry flag, the new carry flag will become 0. Tell me why this new carry flag has become 0? Why this new carry flag has become 0? Because you can see this this LSB. Sorry, this LSB was 0. Yes or no? This LSB was 0. Because this LSB is 0, so the carry flag has become 0. Okay, because LSB was 0. Very simple. Okay, now tell me what will happen. Now the carry flag, you already know, because of this, what will happen? The carry flag has become 0. Okay, the carry flag has become 0. So this condition will be unsuccessful because this is saying jump to Y if carry flag is set. Jump to Y if carry flag is set. So this is also unsuccessful. Because this is unsuccessful, so this you will go to jump Z. So directly from here, you will go to here. Yes or no? So you will not increase the value of b. So you will not increase the value of b. In second iteration, value of b not increased. Yes or no? In second iteration, value of b not increased. Value of b not increased. Okay. Now, did you understand? In two iterations, did you understand what is happening? Now, did you understand what is happening? Tell me. In two iterations, now the third iteration will start. But tell me, in two iterations, did you understand what is actually happening? Let me know. Actually, this is happening. See, when the value of b will increase, you just tell me, when this will happen. You just tell me when this will happen. Okay, one by one, let's see. One by one, let's see. When this will happen, tell me. When this will be executed, this will happen when you go from here to here. Okay, yes or no? See, this will happen when you jump from here to here. So this must be successful. And when this will be successful, and when this will be successful, this will be successful when the LSB of A is 1. Agree with me? Do you understand? Please tell me. See, this will be successful when carry flag is 1. I can say this will be successful when carry flag is 1. This will be successful when carry flag is 1. Now tell me when carry flag will be 1. So when carry flag will be 1. So this for this to become successful, what should happen? So what should happen? So here what should happen? Here this should happen that here I can say LSB of A must be 1. Okay, LSB of A must be 1. Is this clear? Please tell me. So this is the overall thing that is happening. And in every iteration, the value of C is decreasing by 1. So how many iterations will be there? Because in every iteration, the value of C is decreasing by 1. In every iteration. So how many iterations will actually happen? See, the initial value of C was actually 8. C was actually 8. In every iteration, you can see, in every iteration, the C value will decrease by 1, 1, 1, 1, like this. Okay, until it will go to 0. When it will go to 0, then in the next iteration, what will happen? When it will go to 0, once it becomes 0, let's assume, okay, once it becomes 0, now in the next iteration, now when you come back either from here or from here, when you come back, then what will happen? Then this 0 flag will be set and you will go like this, and you will go to X. Yes or no? Is this clear? Please tell me. Then you will jump to X. So remember, there will be total 8 iterations will happen. Total 8 iterations will happen. Total, remember how many iterations will happen? Total 8 iterations will happen. Okay, understood? Simple, right? Yes or no? So quite simple. So total 8 iterations will happen. Now let's do. So this is the final idea. So tell me, what will be the value of B? What will be the final answer? We will do the complete, don't worry. I will do the complete, all the iterations I will do, but you tell me what is the final answer? What will be the final answer? So the value of B after execution. So I can say after complete execution, what will happen? The value of B that will be equal to number of ones in A. Yes or no? That will be the value of B will be equal to the number of ones in A. The number of ones in A. Yes or no? Okay. Anyway, if you did not understand, don't worry. But this is your answer. That value of B, that will be number of ones in A. Okay. Is this clear? So this is the simple idea. But if you did not understand, do not worry. Let's do the third iteration. Okay. Let me do the third iteration. I'm here. Where I am? I'm here. Yes or no? Now let's start the third iteration. In the beginning of the third iteration, tell me what is the value I have in each register. In each register, what is the value I have? Tell me. Now we will start the third iteration. In the beginning of third iteration, what is the value of C? So the value of C, that now has become 6. Okay, that value has become 6. You know that carry flag, that has become 0. Because of what? The carry flag has become, okay, actually we went from here to here. So the carry flag actually has become what? That has become 0. That we already know. Okay, that has become 0 because here you can see the carry flag has become 0. And what is the value of A? That is 0, 0, 0, 1, 1, 0, 1, 1. Okay, the value of A, what is that? 0, 0, 0, 1, 1, 1, 0, 1, right? Okay, so you can see 0, 0, 0, 1, 1, 0, 1, 1, sorry, 1, 0, 1, 1, sorry. That will be 1, 0, 1, 0, 1, 1. Okay, so these are the values. You can see in the beginning, these are the values. After this instruction, what will happen? Please tell me. After this instruction, what will happen to 0 flag and what will happen to carry flag? After this compare instruction, when you execute this compare instruction, then what will happen to 0 flag? What will happen to carry flag? So here you can notice the 0 flag, that will be 0. Okay, you are doing the comparison. So you can see C value is already 6. So the 0 flag will be 0 and the carry flag also will be 0. Okay, both of them will be 0. Now after this instruction, this is unsuccessful. What will happen? This will become unsuccessful. This has become unsuccessful. In this instruction, what will happen? The new value of C has become 5. Okay, C will decrease by 1. The new value of C has become 5. What is the value of carry flag? Please tell me. What is the value of carry flag? This is subtraction. This will affect the carry flag. This is subtraction. This will affect the carry flag. There is no need to borrow because 6 minus 1. You are doing 6 minus 1. So there is no need to borrow. Because there is no borrow, so carry flag 0. Okay, and what about 0 flag? That is also 0 because result is not 0. Because result is not 0, so 0 flag is not set. Okay, now what you will do? Now you will do right rotate A one time. What is the value of A? What is the value of A? If you look at what was the value of A? The value of A was 0, 0, 0, 1, 1, 1, 0, 1, 1. Yes or no? This is the value of A. What is the value of carry flag? The value of carry flag, that is 0. The value of carry flag, that is 0 because you can see the value of carry flag is 0. Now again you will do the right rotate. Okay, again everything you will rotate. Everything will shift to the right. Everything will shift to the right. This 0 will go here. So what will be the final value of 0? A. The final value of A, that will be 4, 0 and then 1, 1, 0, 1. This will be the value of A and the carry flag has become 1. Why carry flag became 1? Why carry flag became 1? This 1 has come here, right? Yes or no? Because the LSB was 1. Because the LSB of A is 1. LSB of A is 1, right? Okay, in this register A, LSB is 1. So that is the reason carry flag has become 1. So now the carry flag has become 1. The carry flag has become 1. So now you tell me carry flag is set. That is set. So now you can see because carry flag is set, so jump to Y. Carry flag is set, so jump to Y. So now you will jump to Y. Now the value of B. Initially the value of B was what? That was 1, right? Yes or no? That was 1. Now the value of B will become what? That will become 2. Okay. This is addition instruction. Will it affect the flags? This is addition instruction. Will it affect the flags? Will it affect the flags? Yes. Carry flag, because there is no carry, right? You are doing 1 plus 1. You are doing 1 plus 1. There is no carry. So carry flag will be 0. And the 0 flag, the result is non-zero. The result is non-zero. So 0 flag is also 0. Yes or no? So this is what will happen in this instruction because of this addition instruction. Now then jump will happen. Now finally again you will go to Z. Is this clear? Finally you will again go to Z. So slowly are you getting the point? Slowly are you getting the point that see this B value, this is increasing because of ones in the A. Yes or no? In this A, okay, this LSB, if this LSB is 1, then this value of B is increasing. Yes or no? Is this clear? So very simple point. So I think there is no need to go further. So can I conclude that finally in this program what is happening? See, in this program overall this is happening. Let me tell you what is the overall conclusion. In this program what is happening? in this program, what is happening? You can see initially, if you notice, the value of C was 8, the value of B was 0, and the value of A was some random, value. So let's assume that value of A, that was some random value was there. Okay, so there is, let's assume that random value is like this. Let me take some random value I'm taking. Okay, so let's assume 5 0 and 3 1s. Okay, let me take this value. Okay, let me take this value, right? Is this clear? Or maybe if you want, let me take this value, no problem. Let me take this value. So you can see this is the value I have taken. Randomly I am taking. So this is your actually randomly I have taken. Randomly taken. In this you can see number of zeros. How many? How many number of zeros are there? Number of zeros, that is 5, and number of ones, that is 3. Yes or no? So you can see this is the value of A I have taken. Now in this question, let me tell you overall what is happening. This is the loop. There is a loop, right? Either this is, see, there is a loop here. In this program, either there is loop like this or there is loop like this. So, but there is a loop. You can see either you are jumping to Z from here or you are jumping to Z from here. These instructions you are executing only once. These are executed once. Okay. In every instruction, what is happening? In every instruction, you are subtracting the value of C. Okay. And remember, this comparison is done based on C. So you can see in these two, in all of them, you can see the C value is decreasing and you are doing the comparison based on C. And remember, only this will take you to X. Okay. Only this instruction can take you to X. So 8 instructions, 8 iterations will happen. Yes or no? In every iteration, C value will decrease. Okay. And you are comparing with 0. When C value will become equal to 0, then you will go to here. Okay. So you can see when C value becomes 0, then you will go to X. So you can see when C becomes 0, then we jump to X, then go to X. And remember, C value is decreasing in every iteration. So very simple. So finally, I can say that 8 iterations will happen. Yes or no? So let's see the number of iterations. In this program, how many iterations will happen? In this program, number of iterations will be 8. Why? What are the reason? Let me tell you the reason. Reason is like this. Because C value initially is 8, then this will become 7, then this will become 6, then this will become 5, and so on. And finally, when it will become 0, finally, when this will become 0, then no next interest, then no more iterations. Yes or no? Here, no more iterations will happen. Here, no more iterations will happen. So I can say that only total 8 iterations will happen. Okay, total 8 iterations will happen. Very simple. In every iteration, what is happening? Now let's see in every iteration. Now let me write in every iteration what is happening. Okay, now let's focus on every iteration. Is this clear? I am focusing on every iteration. Now focus on this program, which is for every iteration. Okay, so in every iteration, actually, if you notice, then these are the things that are happening. Okay, this is the area that is executed in every iteration. In every iteration, you are doing this. Actually, what is happening? When the LSB of A is 1, okay, then you can say carry will be set. Yes or no? You can easily see. You can easily see that. Look at only these. When, so here I can say that when LSB of A is 1, then carry flag will be set. Okay, then this instruction will set the carry flag. Then this RRC instruction sets carry flag equal to 1. Okay, yes or no? Then what will happen? Then this jump if carry to the location Z, sorry, to the location Y, then this will be successful. Then this becomes successful. Then this becomes successful. And because it becomes successful, so you will go to Y. Because it becomes successful, so what will happen? So you will go to Y, you will go here. So the value of B will increase. So B increases by 1. B increases by 1. Is this clear? Let me know. So finally B is increasing by 1. And tell me when this LSB, when this LSB of A, if that is 0, then what will happen? If LSB of A that is 0, what will happen? If LSB is 0, then in this situation you will directly jump. Yes or no? In this situation you will directly jump. So you can see that when LSB of A is 1, then this will happen. And when LSB, when this will happen when LSB of A is equal to 0, then you will directly jump to next instruction. Okay, so you can see then next instruction starts. Then next iteration starts. Iteration starts. Is this clear? This is happening in every iteration. Please let me know. Is this point clear? So this is what is happening in every iteration. One more thing is happening in every iteration. What is that? In every iteration, one more thing is happening. So let's continue. In every iteration, what will happen? One more thing is happening, that is A is shifted. Yes or no? A is shifted. A is shifted right. Agree? A is shifted to right. And this carry flag inserted, okay, to MSB of A. Now you tell me just one thing. You just tell me one thing. This carry flag Z that is inserted in the MSB of A, that will always be 0. Yes or no? Did you notice? See, a very simple point I'm asking. You just tell me, before this right rotate, before this instruction, carry flag will always become 0. Here, because of this subtraction instruction, this will affect carry flag. This will affect the flags. Yes or no? This will affect the flags. So did you notice one thing? Before this instruction, carry flag will always become 0. Do you agree? Please tell me. Carry flag will always become 0, right? Yes or no? Is this clear? Because you are doing C minus 1. Okay. So always C value, that is always greater than equal to 1 whenever this instruction will be executed. Is this clear? Like for example, 8 minus 1, 7 minus 1, 6 minus 1, 5 minus 1, 4 minus 1, 2, 3 minus 1, 2 minus 1. Yes or no? 1 minus 1. So this is what I'm saying. The carry flag before RRC instruction, carry flag is always 0. Please tell me, is this point clear? Let me know. Let me know. You can see one thing, that just before RRC, just before RRC instruction, carry flag, this carry flag is always 0. Is always 0. So what is happening? So finally, what I can say? I can say that you are inserting 0, right? Yes or no? So this simply means, it simply means that in every iteration A is shifted. In every iteration, what will happen? In every iteration A is shifted. In every iteration A is shifted to right. Okay, and zeros are inserted because carry flag is always 0. Yes or no? Are you are inserting the carry flag. You are inserting the carry flag to MSB of A in this RRC instruction. In this RRC instruction, yes or no? In this RRC instruction, you are inserting the carry flag to the MSB of A, but carry flag is always 0. Before the RRC instruction, just before the RRC instruction, the carry flag will always be 0 because of this subtraction instruction. This subtraction instruction will affect the flags. Because of this subtraction instruction, the carry flag will always be 0 before the RRC instruction. Okay, before you execute this right rotate A, right rotate through carry, before you execute this instruction, the carry flag will always be 0. So I can say in every iteration, what is happening? This A is shifted to the right and zeros are inserted. And zeros are inserted. Okay, is this clear? And zeros are inserted on MSB. Please tell me. Understood? Let me know. So finally, yes, at the end A will be 0. Very good, very good, very good. So at the end A will be 0. At the end, what will happen? A will be 0, and that is your another question in the same year. That is your question number 49. See, this is question number 48. This is question number 48. This is asking the value of B. And there is question number 49. This is question 49. What this is asking? This is question 49. What this is asking? Tell me. Question 49 is asking that you again want to restore the value of A. Okay, the question, actually question 49 is asking about the value of A. So finally, you tell me, this is what will happen. So I can say at the end of the execution, tell me what will happen. So remember, simple point, at the end of the execution, at the end of program execution means when you reach the label X, means when we reach the location X. Okay, there is a location X. This is the location X. So when you reach this location X, then what will happen? Tell me all the things. You tell me what are the values of all the registers. So what will the value of A? That will be all 0, right? That will become all 0. Yes or no? Is this clear? Whatever is the initial value, that will always, the final value will always become all 0. Whatever be initial value. Whatever be the initial value, this will always happen. What is the another thing? What will be the value of B? That will be number of ones in A. Yes or no? Number of ones in A, in initial value of A, or I can say A0. Number of ones in initial value of A. Initially, A0 means that is the initial value of A. Value of A. What will be the value of C? At the end, that will become 0. C will become 0. Yes or no? So that's it. So these are the things. Is this clear? Please tell me. Is this understood? Did you understand this question? Please tell me. The complete explanation I told you. Yes or no? A very simple program is given to you. This simple program is given and we have seen everything what is happening. You tell me one thing. If this question comes in the GATE exam, and let's assume you start with this value. Okay, let's assume you start with this value. Right? Yes or no? Now you tell me, after how many iterations you will get to know what is the answer? Let me tell you, if this question comes in the GATE exam, I can guarantee that after 2 iterations or maybe 2-3 iterations, you will automatically find out what is happening. After 2-3 iterations, you will see, you will know what is happening. Is this clear? Please tell me. After 2-3 iterations, you will find out what is happening. You will find out what is happening with the value of B, with the values of ABC. Yes or no? So do you agree with me? Do you agree with me that after 2-3 iterations, you will find out what will happen with the values of ABC? So these questions are very simple. Okay, these are actually very simple. This explanation, did you understand? Let me know. Okay, so for this question number 48, what will be the answer? For the question number 48, the answer will be what? Let's see. For the question number 48, the answer, you can see, the answer will be option B. Yes or no? Number of ones in A0. That will be your answer. Simple. Answer will be option B. That will be your answer. Okay, simple. Now let's move on. What about question number 49? What about question number 49? You tell me. The question number 49, the same code, the question is saying, which of the following instruction you need to insert at location X, which will ensure that the value of register A after program execution is same as the initial value? Did you understand? See, here you can notice, we have already seen if the initial value, if that is like this, okay, whatever you take, whatever initial value you take, right? Whatever initial value, if this is initial value, if this is your A0, we already know what is the final value. Always this will happen, right? Yes or no? always this will happen. Always, whatever A0 you take, whatever A0 you take, what will be the final A? Please tell me what will be the final A? That will be all zero. That will be all zero. Yes or no? Final A will always be all zero. So now you tell me. Now the question is saying we want to go back to A0. Is that possible? We want to go back to A0. Is that possible? See, always whatever A0 you take, whatever A0 you take, whatever A0 you take, the final value will be this. Final A value will be this. So can you go back to A0 using these options? Is it possible? Using these options. Okay, if you do right rotate through carry one time, can you go back to A? Can you go back to A? Please tell me. Let me know. Can you go back to A? If you right rotate carry through carry one time, you cannot go back to A. If you don't do anything, can you go back to A? Can you go back to A0? I cannot go back to A0. Okay. If I do left rotate through carry Y one bit, can I go back to A0? I cannot go back to A0. If I add 1, can I go back to A0? I cannot go back to A0. So which option is correct? So which option is correct? So no option is correct. Okay, is this clear? So no option is correct. For this question, none of the options is correct. Okay, so there is actually mistake in this question. Okay, so in the GATE exam in 2000, you can see this is 2003 question. So for this question, I can say for the question 49, there is answer. There is answer B. For the question 49, answer is B. Okay, there is no problem here. But for question 48. For question 48, answer is B. But for question 49, no option matches. No option correct. Is this clear? For this, no option is correct. Actually, let me tell you one thing. Let me tell you one thing. Where is the problem happening? Actually, where is the problem happening? The problem is happening because these instructions are affecting the carry flag. See. Let me tell you where is the problem. Okay, I'm telling you where is the problem. The problem is like this. See, this instruction is rotating through carry, right? Yes or no? This instruction is rotating through carry. This instruction is rotating through carry. Okay, so this instruction is rotating through carry, but after that, what is happening? See, but after that, these instructions are making carry 0. This instruction making carry 0. This instruction is making carry flag 0. Okay, yes or no? Similarly, this instruction making carry flag 0. Correct? These instructions, they are actually making carry flag 0. Even this instruction is also making carry flag 0. Making carry flag 0. Is this clear? Please tell me. So actually what is happening, let me tell you. The problem is this. The problem is like this. See, if they do not affect the carry flag, if these instructions, if these instructions, they do not affect the carry flag, then what will happen? If these instructions do not affect the carry flag, then there is no problem. Yes or no? If these instructions do not affect the carry flag, then there is no problem. Then there is no problem. Then what will happen? Then this will happen. See, then this will happen. Notice. Just assume if, for example, what I am saying, instead of this addition, you are adding +1. So which instruction you can use which will not affect the carry flag? Please tell me. You are adding value 1. You are adding value 1. Which instruction you can use instead of this? Instead of this, which instruction you can use? Tell me, which instruction you can use? Yes, you can use increment. Increment, will it affect the carry flag? Will it affect the carry flag? Please tell me. Increment, will it affect carry flag? It will not affect carry flag. Similarly here, which instruction you can use? You can use decrement. Decrement you can use. That will not affect carry flag. Okay, that will not affect carry flag. Also, it should be given that compare will not affect carry flag. Yes or no? It should be given in the question. It should be given that compare will not affect carry flag. Okay, yes or no? Are you getting my point? So remember, instead, if you use this, 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 and also, it should be given that CMP does not affect carry flag. So these three things, if they are given, now you tell me what will be the answer. CMP does not affect carry flag. If these things are changed, please tell me. I am saying that, see, please understand. If, okay, if three changes made, if we make three changes, if three changes are made in the previous question, in what are the three changes? Three changes are this. Instead of this addition instruction, what you do? Instead of this addition instruction, what you do? Please tell me. You use increment, right? Just use increment. Similarly, instead of this subtraction, you are doing the subtraction by 1. Instead of this, if you use decrement instruction, no problem. And the third thing, given that, okay, given that CMP does not affect carry flag. Carry flag. Okay. CMP does not affect carry flag. If these three things are given, okay, if these three changes are made, now what will be the answer? Now what will be the answer? Tell me. If these three changes, if I make these three changes, now what will be the answer? Now actually what will happen? Now see, now something like this will happen. Now you can notice the A. A will start from where? Just focus on A, okay? Let's focus on A. Let's assume that A is this. Let's assume A is this. Initially A is this. This is A0. This is your A0, means this is initially. Now what will happen? Okay, remember these instructions, they do not affect carry flag, right? Because this you already know. Okay, we already know that these instructions, they do not affect carry flag. Note that increment, decrement instructions, they do not affect carry flag, right? Instructions do not affect the carry flag. That you already know, that we have already seen in our previous lectures, that increment, decrement, they do not affect the carry flag. So you can see now, okay, now the only instruction which can affect carry flag, that is your RRC. Yes or no? Now only RRC can affect carry flag if previous three changes are made. Now, if previous three changes are made, if previous three changes made, then who is the only instruction who can affect the carry flag? Please tell me. If these three changes are made, then the only instruction who can affect carry flag, that is RRC. That is RRC. So you can see, if previous three changes are made, then only RRC instruction can affect carry flag. Can affect carry flag. Okay, only that instruction. Only RRC instruction can affect the carry flag. Now you can easily see what will happen. So initially carry is 0, that you already know. Initially carry 0. Initially carry 0. Carry flag is 0, that you already know. So here also one thing. Okay, the initial carry value, that will be inserted. Yes or no? Initial carry flag, whatever. See, initial carry flag, that you already know, that is 0. That you already know. Yes or no? Okay, so let's assume this was the initial value of A. Just assume. Just assume. Okay, no problem. See, because you know this is the initial value of carry flag. Now tell me, after first iteration, what will happen? Tell me after first iteration. Okay, just let me know. After first iteration, what will happen? Please tell me. Focus on A only. After first iteration, or I can say in first iteration, what will happen? Tell me. what will happen to the value of A? What will happen to the value of A? That will become 0, 1, 1, 0, 0, 1, 0, 1. And what will what this carry flag will become? This will become 1. After the second iteration, what will happen? After second iteration, what will happen? Tell me. After second iteration, what will happen? Let me know. After second iteration. So if you notice, actually, just for a moment, let me write it. Let me write it like this: that you have A8, A7, A6, A5, A4, A3, A2, A1. Okay. And the carry flag is initially 0. That you already know. The carry flag is initially 0. Here also, let me write it C. Okay. Whatever. Basically, just let me write it C. Initially, that is 0, but let me write it C. Let me call it C. So you tell me after first iteration, what will happen? After first iteration, you can notice this will become C, A8, A6, A7, A6, A5, A4, A3, A2. And this carry flag will become what? That will become A1. Yes or no? After second iteration, what will be the A? After second iteration, remember, carry flag now no one is affecting. No other instruction is affecting the carry flag. Remember, now if you again come back to RRC, what will happen? Now, when you again come back to RRC, what will happen? No one is affecting carry flag. After the 3 changes, the previous 3 changes, once you make the previous 3 changes, no one else, no other instruction is affecting the carry flag. So when you come back to RRC in the next iteration, in the second iteration, when you come back to RRC, the carry flag will still have A1. The carry flag will still have A1. Yes or no? So after the second iteration, what will the value of A? That will be A1, C, A8, A7, and so on, A3. And the carry flag will become what? That will become A2. Is this understood? Please tell me. Now tell me after the final, at the end, what will happen? At the end, what will happen? At the end of execution. At the end of execution, what will happen? Please tell me. What will be the value of A? You can easily see. After the second iteration, you have A1 here. In the next iteration, you will have A2 here. Okay. After third iteration, the next iteration, you will have like this: A2, A1, C, A8, and so on, A4. And this will have A3 like this. Yes or no? Is this clear? So tell me, at the end, what will happen? At the end, what you will get means after the 8th iteration. At the end means after 8th iteration. After 8th iteration, what will happen? Please tell me. This is after third iteration. This is after third iteration. You can see. Okay, this will happen from here. From here, you are going here. Okay, after the next iteration. This will happen after third iteration. You tell me about at the end what will happen. Tell me. Let me know. At the end, what will happen? You can easily see at the end what is going to happen. You will have C. Yes or no? You will have C here. C. At the end, this is what you will have. C here. Okay. This A. A will be like this. It will have C. And there will be A7, A6, A5, A4, A3, A2, A1, C. Yes or no? And what carry flag will have? What carry flag will have? Carry flag will have A8. Okay, is this clear? See, you can easily check. There is nothing here. Okay, if you again do, then after the end, after 8th iteration, you tell me. After 8th iteration, what will happen? This will be the content of A, and this will be the content of carry flag. Now you tell me, at the end, you are at X. When I say at the end, when you are at, we are at location X. Now we are at location X. When you are at location X, now you tell me, at this location X, what should be there? At this location X, what should I put so that I get A equal to A8, A7, and so on, A1. I get this value. What should I put here? Very good, very good. Just do one more right rotate through carry one time. Yes or no? Is this clear? Just do one more time. Just do one more time and you will get this value again. Is this clear? So for this question, what will be the answer? If other, so for this question, if other instructions, if only, I am saying if only RRC affects carry flag, then what will be the answer? Please tell me. If only RRC affect carry flag, then what will be the answer? Then your answer will be option A. Is this clear? Did you understand this question? Please tell me. But for the original question, none of the options will match. Okay, for the original question, none of the option is correct. Please tell me, did you understand? Let me know. Question number 48, question number 49, did you understand? Please tell me. Did you understand question number 48, question number 49? Anyone has any doubt? This was a quite beautiful question, right? Yes or no? This type of questions will come in the GATE exam. You just have to do simple analysis. Okay, yes or no? Just do simple analysis. Do 2-3 iterations. In 2-3 iterations, you will get the idea. I promise you. If this type of question comes in the GATE exam, just do 2-3 iterations you do. In 2-3 iterations, you will get the idea. What is the answer? You will get the idea. Anyone has any doubt in this question? In this particular question, question number 48, question number 49, the analysis that we have done, anyone has any doubt? Let me know. The complete analysis we have done. I have told you for every instruction. Okay. After every instruction, what will happen? What every instruction will do? Everything we have seen. The complete analysis we have done. So this is the idea. Okay. Let's move on now. One more thing I want to ask. If you are in GATE 2003, if you are present in the GATE 2003, okay, and you find out that, okay, no option is correct, right? Yes or no? Let's assume you are sitting in GATE 2003 and you find out that no option is correct, no option is correct. Then will you leave the question? If you find out that no option is correct, will you leave the question? No, don't leave the question. Just understand what the examiner, where examiner made the mistake. Just try to think where the question maker made mistake. Yes or no? Just try to think where the question maker made mistake. If you look at the options, you will easily see the question maker made mistake by putting add instruction is instead of increment. Yes or no? Instead of increment, the question maker put add instruction. Instead of decrement, the question maker is putting subtraction instruction. Yes or no? And you know, addition, subtraction, they will affect the carry flag. So that is the problem. Okay, once you find out that, okay, this is the problem, the question maker made mistake here. Once you find out, okay, by looking at the options, once you find out what is the mistake, then you can easily see that, okay, question maker is thinking that answer will be option A. Okay, question maker is thinking answer will be option A. But of course, this question you can challenge. Is this clear? Remember, after the GATE exam, of course, whatever answer they give you, you can challenge it. Okay, so this question will become marks to all, right? Yes or no? This type of question, what it will become? For question 49, no option matches. No option matches. So what I can say? So this actually will become marks to all if you challenge it. This will become marks to all if we challenge it. Okay, if challenged using standard resources. Using standard resources. So using the standard resources, you can challenge it and it will become marks to all. So don't worry about this type of questions. Okay, this type of ambiguous questions, don't worry. Is this clear? Please tell me. Do not worry about this type of question. This is what I'm telling you. This type of question, question number 49, no option is correct. Okay, your concept is correct, but no option is correct. So this type of question will be marks to all when we challenge it using the standard resources. It happens every year. Remember this point. Every year, 1-2 questions, or I can say 2-3 questions become marks to all. Is this clear? Become marks to all, or or multiple or marks given for multiple options, or marks given for multiple answers. For multiple answers. Is this clear? Please tell me. So remember, every year this happens. Every year 2-3 questions, they become marks to all, or marks are given for multiple answers. So do not worry about this type of questions. Just follow the correct concept. That is my suggestion. This is my suggestion to you. Just follow the correct concept. Okay, just follow the correct concept. One thing I want to tell you, this is what I have seen in the coaching institutes. Okay, what I have seen in the coaching institutes, that is what I want to share with you. Let me share. Actually, for this question number 49, no option is correct. That you already know, right? Yes or no? No option correct. No option correct. But what the coaching institutes will do, there are some teachers in the I can say in the very big coaching institutes. Let me tell you, there is a teacher. I will not name. Okay, but anyway, I am just telling you what the coaching institutes will do. Now, you know, there is no option correct, but they will somehow try to get the correct, basically get the answer option A. Okay, what they will do to get the answer A, just to get the answer A, so that they can get the answer A, what they will do, let me tell you. You can see their notes. Actually, they will do something like this, that this operation uses extra bit. This type of concept they will teach you, that there is an extra space. There is an extra space of 1 bit. Means this extra space of 1 bit is there. See, this is what I have seen. That is what I'm telling you. This is true. Okay, thousands of GATE aspirants who are preparing in those big institutes, okay, from those big teachers, actually what they are learning, let me tell you. You can see in this question, no option is correct. Okay, but these people, what they will do, somehow they will change the concept to get the option A. Okay, yes or no? This is what they have done, let me tell you. And even they are today also they are doing, for the last 10 years, for the last 15 years, they are doing this. Okay, they have changed the concept. The concept they have changed so that they can get the answer option A. Just to somehow get the answer option A, they have changed the concept. What they are saying, you will see in their notes, this is what they are saying, that right rotate carry A1, in this rotation happens through some extra space. Okay, this is the concept they will teach. They will teach you, what they will teach you, let me tell you. They will teach you that rotation happens. This is what they will teach you, that rotation happens through extra space, not through carry. Through extra space. Okay, means there is some extra space, not through carry. Not through carry. Okay, means there is some not through carry. So basically, this is the type of thing they will teach you. Actually, this you can find in the notes of thousands of students. You can find this. You know, this is true. This is true. Okay, they will change the concept just to get the answer. They will change the concept. So this is what they will say. They will say that rotation will not happen through carry. The rotation will not happen through carry. There is some extra space of 1 bit. Some magical space of 1 bit. Some magical space of 1 bit. Okay, this is not carry. This is not carry. This is not carry flag. This is what they will say. They will say that this is not carry flag. This is a magical space. This is some extra space of 1 bit, and the rotation will happen like this. The rotation will happen through this. So the rotation will not happen through carry. Are you getting my point? Did you understand what I'm saying? So rotation will not happen through carry. It will not happen through carry, but it will happen through some magical extra space. Now let me tell you, there is not a single standard resource which has this concept. First of all, there is not a single standard resource. You can study William Stellings, Hamacher, Patterson. You can Morris Mano, check any standard resource. I'm telling you this. And if that teacher, you know, those teachers who are teaching this wrong concept, extra space concept, you know, there is extra space. Actually, why they are teaching this concept? Please tell me. What is the reason they are teaching this wrong concept? Because somehow they want to get answer option A. Okay, by hook and crook, they want to get answer option A by hook and crook. So they are changing the concept. They are changing the entire concept. Okay, they are teaching the wrong concept to thousands of the students from the last 10-15 years. Okay, So you can see this type of concept they will teach, that there is extra space of 1 bit. Actually, this is nonsense. You will not find in any standard resource. You can study Morris Mano, you can study William Stellings, Carl Hemcher, Patterson. These are the standard resources. These are the standard books. Okay, other than these, you can Google, okay, and search on the university articles. Just go through the standard university articles. Okay, don't go to Indian websites. Do not go into the Indian websites. You know, there are some websites are there who will teach you the concepts. Okay, there are some websites, Indian websites, who will teach you the concepts. Don't go there. Okay, just directly go to the standard resources. Always follow the standard resources. So you will not find this nonsense concept anywhere. This nonsense concept you will not find anywhere. Is this clear? Please tell me. Is this point clear? This nonsense concept you will not find anywhere. There is not a single standard resource, not a single standard resource which contains this type of nonsense concept. Okay, this is what I'm telling you. You can check. You can check after the GATE exam. You can check. Okay, is this clear? And actually, you don't have to check anything. Everything is given here. Even the GATE question itself is given everything. You don't have to check any standard resource. The GATE question itself has given everything. Yes or no? You can see the rotation is happening through carry. The rotation is happening through carry flag. Every information is already given to you. Agree with me? Please tell me. Is this clear? See, the question itself is telling you the carry flag. The rotation is happening through carry flag. You don't have to go anywhere. But still these wrong concepts people are teaching. Okay, so anyway, this is a pure nonsense. What is this? This is pure nonsense. Okay, this is pure nonsense. Anyway, and this is very unfortunate. Sometimes it makes me very sad, actually. It will make you sad also. This is very unfortunate that thousands of students every year, they are learning this type of wrong concepts, this type of nonsense concept, which is not found in any standard resource. If you want to search standard resources, you will never find this concept, this type of extra space. Okay, this type of, I can say, mangadant. You know, in Hindi there is a word mangadant concept. So these are some mangadant concepts. These teachers, they are making their own concept. Okay, so anyway, these are pure nonsense things. So anyway, okay, let's move on now. Let's solve this question. So can I give this question as a homework? Let me know. Can you try this question? Please tell me. Can you try this question? This question, you just try. Get 1999 question. Just try yourself. I have full confidence on you. You can do it. Okay, this question you can easily solve. Just try this. Try yourself. You can solve it. Okay. So just try. Okay, we will discuss this. In some other session, we will discuss this. Okay. Is this clear? In some other session, we are going to discuss this question also, but you try this. Actually, this is a very simple question. This program is given to you. You can notice this program is given to you. You just have to execute this program. Okay, and when you are executing this program, you will automatically find what is happening. You will automatically find out what is happening. So try this question. If you want, you can check the explanation on the GATEOverflow website. But don't worry, this question we will discuss in some other session. Okay. Okay. Thank you, everyone. Anyone has any doubt? Let me know. Do you have any doubt? Please tell me. So far, whatever we have seen in computer organization, all the concepts that we have seen, is there any doubt in any concept? Please tell me. In this lecture or in the previous lecture, do you have any doubt? Satyam is asking, if carry flag is not affected, then how to check x is less than y? Satyam, actually, basically, what I'm telling you, that the compare instruction, some other implementation will happen. It's not like, see, the compare instruction, maybe they are doing some internally, they are doing some other implementation, right? Yes or no? See, you can compare in many different ways. Either you can do the subtraction or you can do some logical comparison. Okay, so this is what I'm telling you. When I'm saying that it should be given that compare instruction will not affect the flag, will not affect the carry flag. If this is given, then what it means that compare instruction internally it is using some other logic. Is this point clear, Satyam? See, compare instruction by default, if no information is available, if no information is given, then compare instruction internally it will use the subtraction. Yes or no? But maybe some other logic it is using, because of that carry flag is not affected. Are you getting my point? Please tell me, Satyam. So this should be given. Compare instruction internally how the comparison is happening, how you are doing the comparison. Okay, maybe that is something else. Yes or no? To compare internally you are using some other logic, because of that maybe carry flag is not affected. So these type of things should be given in the question. If it is given, then you can solve, okay, everything I told you. Is this clear? Please tell me, Satyam, let me know. Any other doubt? Any other doubt? Anyone has any other doubt? Please tell me. Okay, so thank you everyone.